Welcome back to Check-In. We've got our last team for the evening. It's Team 5803, Apex Robotics. They're from SeaTac, Washington. Welcome to the show, guys. Thank you for joining us once again. Why don't you go ahead and introduce yourselves for everybody at home?
Hey everybody, I'm Evan Morrison. I'm one of the lead mentors.
Hi, I'm Jennifer Hogue, and I'm one of the documentation students.
Hi, I'm Casper Lodge. I'm one of the mechanics.
Cool. All right, well, welcome to the show, guys. So let's get started. Let's first talk about the practice robot. So we saw in your video there that the practice robot, it's spinning, it's moving. Tell us about what you guys did this past week to get there and what you've learned so far from it.
Yeah, so we put in a lot of work mechanically to get it, I'd say 95% mechanically complete. And then we handed it over to the software team pretty late last Saturday. And they took good care of it, and they made sure that all the system. They basically did a system check of every subsystem that we have, and everything worked. All the motors spun. Some of them were the wrong direction, and we weren't able to get our drivetrain running yet, but they are currently debugging that problem. But other than that, we've had really good progress on our practice robot. Nice.
So you're only hopefully pretty close to being ready to actually practice and drive the robot around.
Yeah, and we'll talk about that a little bit later on when we talk about what our final weekend looks like. But yeah, our software team is over in the other room right now, kind of frantically trying to get debug the issues and make sure everything runs. We kind of had two issues that prevented us from really doing a full, run the balls through, that kind of stuff. One was the drivetrain isn't moving. We believe that's because it was expecting to have encoders on there, and the encoders weren't installed yet, so it kind of threw a hissy fit. And the other is that, so we're using the new Xbox class instead of the joystick class for controlling. We use an Xbox controller for our operator, who's also Jennifer. And so we're dealing with some differences with that compared to last year. And so we can turn every system on, but we can't always turn it off. And until we can reliably turn it off, we're not going to run everything with balls through it.
Okay, I guess it's probably kind of important to be able to turn stuff off, I guess. But okay, so since you haven't got everything completely running, but have you learned anything about what you're going to do differently for your real robot from this practice robot? Everything like the shooter lining up, everything going through okay so far, or what bugs have you run into sort of from a more mechanical standpoint than just trying to get it up and running?
Yeah, so one of the biggest problems that we had was that the rollers that we're using for our elevator system up to our shooter, they were a different size in the CAD than they are in real life. And also for our gear mechanism. But we solved the problem temporarily on the practice robot by putting grip tape onto each of the rollers. And so that basically just made the diameter bigger to the size that we wanted.
Okay, so they were too small, not too big.
Yeah.
Okay, that's the preferred way to do it, I suppose.
Yes.
Yeah. And then what we did for competition robot, knowing that it needed to be bigger, is we bought some of the latex tubing. I think 319's using that on their ball elevator as well. And so we put that over the rollers on the competition robot, and hopefully that'll kind of solve the problem the same way, but be a lot nicer and a lot more robust.
Okay, cool. So I don't want to harp on this certainly, but what do you guys think caused the mismatch between the actual roller size and what it was in the model?
Not checking dimensions.
Okay.
And assuming, basically. Yes. Misremembering the actual dimension of the tube, and then telling the students who were working on it the dimension of the tube that was not actually the correct dimension, and so everything assumed that they were 1.5 inches, and they're actually 1.25 inches. Oh
my gosh! So it's actually not. Yeah. It's not even like 5 or 10 thousandths. It's actually
no. It was significant.
Okay.
So we actually ended up spending a decent amount of time last week because we figured that out fairly early on as we ran balls through the system by hand, just moving each piece. And so we realized that pretty early, and we're able to solve that with a combination of the grip tape and shimming the back plate on a few things to make it a little bit tighter.
Cool. All right. So we have a question coming in from the chat. I think we'd like to talk about it right now. So Jacob asked another question here. Why go with this 3 mini sim drivetrain? So we know that's probably not the reason it's not working, I'm going to assume.
No,
but
it's software.
I think we touched on this in a previous episode, but for the people who haven't seen it, why don't you guys tell us about why you're going with 3 mini sims as opposed to 4 or 2 regular sims?
So I'll just go ahead and say what I know. The mini sims, as we found out, they have a higher power input, I think, but they also are more efficient in the power that they use. And so by using 3 of them, I think we get the same power as 2 mini sims, but it's more efficient, and they're also a smaller diameter, and we were able to fit them into our drivetrain that we custom made really easily, and it all worked out nicely.
I see.
Yeah. So they heat up. They have better thermal properties, more thermal mass to the input to the power. So they heat up a little bit less. And they're just smaller, as she mentioned. We were able to pack everything down to the drivetrain. The last little bit is that the way that our drivetrain is set up, which was on a couple previous episodes, we kind of showed it off with the gearbox in the tube.
Yeah.
The only way to really make that work with the 8-wheel drive and the wheel spacing is to have 3 motor stations there. Otherwise, your gears end up being pretty massive, or you have to run chain, and it just doesn't quite fit to do that. So it was kind of a way for us to hack 3 motor spacing without actually going to 6 full sims.
Cool. All right. Well, that sounds good to me. So let's talk to our next topic. Let's talk about the software updates. So we said right now you guys are working hard to get all the bugs together. What about the rest of your software group?
Well, the software team is working to get the bugs out, and the other thing that they're working on is vision. So I know they've finally kind of settled on a camera and some other stuff. But we're running grip on the Kangaroo PC. So I don't know exactly. None of these guys are software guys.
Okay.
Or girls. So that's the kind of extent of my knowledge. But I know right now they're focused on just getting all the systems running and making sure the control buttons work. And then, as Maura mentioned last week, we've got full manual code. And just run balls through the system and make sure that everything works the way we expect.
Sweet. All right, cool. Tuning. Yes, tuning is always the hard part. This is why I personally am always a little trepidatious about shooter years, because I much rather have just an arm I could put on a robot and test, but all that tuning gets a little tricky sometimes. So, which is a good reason you have a practice robot. And speaking of the practice robot, we saw the first images of what looks like will become your competition robot with brand new red gusset plates. Tell us about how that thing goes together.
Well, it's made a majority of aluminum rods, and it's supposed to be fairly compact. We've done a pretty good job of packing it together. The majority of it is more in the center, and we're trying to keep most of our electronics and pneumatics along the side, and the majority of the space is taken up by our fuel tank. And
okay.
It's the majority of our construction right now. We're still working on a hangar, which will go up on the front. But other than that, everything is working well, and we're trying to keep everything compact and keep a lot of space for electronics and pneumatics.
So I think you guys are probably, of all the check-in teams, you guys are starting to build your competition robot the latest of everybody else. Why don't you guys go into a little bit about the process for that and where your robot is right today?
Yeah, so I've been working a lot on the competition robot. It's hard with so few students. We kind of have to share, everybody wants to work on the practice robot since it looks like an actual robot and not just a bunch of random pieces. But we know that it's important to start the competition robot, and we started building it late because we didn't want to make the same mistakes that we made on our practice robot. So we're taking our time, definitely with the drive base. We want that to be square. We want it to be all the holes to line up and everything. So we built the drive bases complete on the competition robot, and it went together really well. We added like bumper latches that we didn't put onto the practice robot, and the magic carpet is starting to be assembled, and the gearer as well is being assembled. And behind us we have the competition shooter. So a lot of the subsystems are being built outside of the robot.
Nice.
Yeah. I think the shooter tower is also being constructed. So we're kind of, as Jennifer mentioned, we learn how to build the robot on the practice robot, and then we take those lessons learned, especially with assembly order, to the competition robot. So we try and get mostly done with the practice robot before we start assembling competition. But our software team has a robot to play with. So we really have, all the way up until bag day to get as much done mechanically and electrically on the competition robot. And then since we're in the district system, we also get 6 hours of unbag time.
Oh, yeah.
That we can spend on the competition robot as well. So while we would love to have the competition robot, up and running and tuned, really we're more worried about just being able to do a power-up systems check before we put it in the bag.
Very cool. So that's a strategy, an approach for it. And it sounds like you guys are assembling it very, very quickly compared to your last robot. Is that right?
Yeah. Once you know how it goes together, and like for me, I don't need Evan to be there supervising my every move. I can kind of put it together a little quicker.
Yeah, the students understand a little bit more about the nuances of how it goes together. The other thing is, when we're building the practice robot, we very frequently find that we have parts that forgot to be ordered, or new parts that we need because the ones that we made or bought don't work quite right. And so now at this point in the season, we've got everything. And so you're really not waiting on any parts to come in.
Cool. So when do you guys think you're going to have
do it? Other than a couple of pieces that are backward.
Okay. When do you guys think you're going to have the competition robot done?
By Tuesday.
There you go.
Yeah.
That's the perfect answer.
The goal is to get it done by Saturday, end of the meeting, probably.
Okay.
Because then we could spend Monday and Tuesday putting electronics on it and all that.
Okay. Nice. Cool. All right. So speaking of that, as we approach Tuesday, slowly we're ticking away to 9 p.m. Pacific time when you guys have to have your robot in the bag. So tell us what the final countdown looks like for Apex.
Well, I'll go ahead and take that. Luckily, our school has a half day this Friday.
Oh, nice.
And then we do not have school on Monday or Tuesday of next week as well.
Oh,
so we're just going to have
a
party at robotics.
Very cool.
Yeah. It's going to be a lot of grinding. Hopefully not as many late nights, since we can work earlier in the day. And yeah, that'll be really nice for us to have that time.
Cool. All right. So does the Pacific Northwest have any week 0 events that you guys are thinking about attending, or do you think you're going to make it to a full field before you put the competition robot in the bag before bag day?
We'll see. There's a couple of fields in the area. None of them are super close, but I think I heard there's a field up in Linwood. I know there's a field down in Olympia. So those are about hour to an hour and a half away from us, which isn't too bad. So it'll really all depend on where things are at. Honestly, with competition robot, even if practice robot is running, just because, as Jennifer mentioned, we have so few students that it's going to be really hard to break off students and mentors to go on an excursion to a practice field before bag day while we're still working on competition robot.
Okay, cool.
Yeah.
So
luckily
go ahead, Jennifer.
Yeah, luckily we have a lot of the rope and a lot of the stuff built here out of wood. So we'll just set that up in our gymnasium sometime and be able to practice with our practice robot, especially climbing. We want to practice that, and just driving around in general, and can be good to practice.
Nice.
Yeah, we have about a half field worth of carpet that we can roll out in the gym in either orientation. We can either do like red half of the field, or we can do like left half of the field. So we can do a little bit with that, at least in terms of getting an idea of distance and time and it takes to do things.
Nice. So I know that you guys, this is only your second year, so there's not a ton of data points for our tradition. But what does the bag day look like for you guys? What was it like last year, and how do you expect that's going to be like this year? You're going to be, do you have any like reveals, or are you just going to work until 9 o'clock and slam the tag closed, or what's it going to look like?
Well, I'll go ahead and talk about last year. It was quite chaotic. But yeah. I mean, it was our first year, and even though we didn't have that like complicated systems on our robot, we had a lot of trouble getting our chain onto our arm, and it took like 2 hours. And Evan was working on it, and I just remember like the frustration. And we all took a picture at like 11:30 p.m. when we finally got it bagged up, and Evan's face was just.
Yeah, I was not happy. I think it was probably 12:30 by the time we took the picture. The robot was in the bag, but
yes,
there's actually a little bit more to that story. Not only it took us 2 hours to get that chain on, and we finally got it on with like a couple minutes to spare, and we hadn't got a chance to power on the robot at that point. So we slam a battery in, power on the robot, and all of the breakers start blowing. Hit the red button, turn off the robot, take the battery out, seal up the bag. Right, we're done. Like, it's midnight.
Yeah, go home.
Go home. Come back. So fortunately, the breakers did their job and protected the power distribution panel. But it turns out that the main battery power was wired backwards in the power distribution panel on the competition robot.
Oh no!
So there are multiple reasons why I was very unhappy after that robot was in the bag. We're hoping this year's a little bit smoother.
Yes.
Yeah, and we have a robot reveal celebration I think the Monday after bag day, so we have some time to kind of recuperate.
So you're going to unbag the robot with the demo provision in the rules, and then sort of demonstrate it, show it off, and then rebag it right afterward.
Yeah, and we'll drive around the practice robot and demo it for sponsors and school members.
Nice.
Yeah. And kind of to make sure we're on the rules, we basically unbag the competition robot and just leave it on the stage and don't touch it, don't power it up, and just use the practice robot to show off.
Okay.
So we're not. It doesn't even get power on during that period of time.
Nice. Alrighty. Well, guys, that's going to do it for the show for this week. I can't wait to see next week. Hopefully, you'll have your competition robot powered up. Maybe it'll be driving, maybe it won't, but at least we'll get a peek at it before it goes away. For everybody else watching at home, next week, 7 o'clock, we're going to start the last episode for the first season of Check-In. And at that point, it's going to be put up or shut up for all of our teams. We're going to show off what they've been working on for the last 6 weeks straight, hours before the rules say that they have to take the robot and put it in a bag until their first event. So everybody who's watching now or watching later on YouTube, follow us on Twitch, follow us here on YouTube, follow us on Facebook as well, so you get notifications of when that show goes live. But Apex, thank you once again for joining us. I'm really, really excited to see everything working and running next week, and I can't wait to see what the final robot looks like. For everybody watching at home, thank you for watching, and we'll see you in just under 7 days for the final episode of Check-In and the final day of the 2017 build season. Have a good night, everybody.